Welcome to Making Real Data Work Accessible in Intro Biology and other courses. I appreciate you sharing some of your data challenges in the chat there. Um, I want to go over our outline for today. I want to talk a little bit about our story at Data Classroom and our design priorities that have gone into our tools. Um, I want to show as kind of a first strategy slash resource for bringing more data into your class. I want to show our resource library, which is a library of curated data sets on different topics. And I want to just we'll go through one of them so you can sort of see what's there, but hopefully I'll give you enough information to explore the resource library on your own and see if one of the data sets in the library would be a good fit for a course that you are teaching. Um, then I want to talk about analyzing student collected data, typically from lab courses. And I want to show you an example from a friend. Her name is Dr. Megan Kobiela at Sweetbriar College. And I want to show you what she was able to do with some lab data in a class and talk a little bit about how Data Classroom allowed her to do that and kind of supported the things she was trying to do in her class. And then finally, I want to show a bridge to our starter activity um, there. And I'm already kind of thinking, in these 45 minutes, we'll probably not have time to really do these activities in number, 2, 3, and 4 in their entirety. But I want to give you a taste, and then I will follow up with the resource materials for anyone who registered for this webinar, and I will post them on the same page that has the recording, and I'll send that out to you. So if you do want to go back and dig into the details a little bit, all of those things will be there. So with that, let's jump on to number one. I was looking over the names of the registrations for today, and I know that there are actually quite a few of you that were new to Data Classroom webinars. So for those people especially, I want to go over the Data Classroom story in brief and talk about some of the design priorities that went specifically into the Data Classroom U version of our platform. Um, the story kind of begins with me as a high school science teacher in the Chicago public schools, and I loved doing work with data with kids in that setting. Absolutely loved leading kids through lab activities, but oftentimes would find that when it was time to actually start working with data that we collected, we would sort of lose enthusiasm as we would just kind of struggle through the mechanics of graph making, and we almost would never spend as much time on thinking about the data as evidence and evaluating the strength of that evidence which is what I was really hoping for with those activities. In 2012, I left the classroom to start a PhD in biology at University of Virginia and got a lot of my data training in that context. And it really got me thinking about how I just didn't really have the right tools that I needed to teach my high school kids how to work with data. Um, that led me to get in contact with some people at the business school at the University of Virginia, the Darden School. Started working with groups that were helping students to start companies, and I worked with two programs, both the iLab and the Catalyst, and that's where we launched Data Classroom. And we were originally just focused on the K-12 space, but in the last few years, we've added a university version of the platform. We're currently working with about 50 universities primarily in intro bio and intro ecology courses. But I think that has just a lot to do with the world that we come from and how we were able to get the word out. Because I do think Data Classroom could be used in a much wider variety of classes at the college level. But that's just where our initial focus is. And like I said, that's where I come from and some of the members on my team come from as well. So we've been really focused on making these tools that allow students to create graphs that generally make data analysis accessible, and that there's just a whole host of ways that we try to do that within the web app. And those are, really every design decision we make is focused on making data analysis accessible without dumbing things down, right? We want students to grow to a place where they're working with data in sophisticated ways, but we just want to make it more accessible. And then the final thing, we provide a bridge to statistical programming in R through the Bridge to R feature, and more recently the Bridge to Python feature. So if it is a goal of yours in the course that you're teaching to eventually move students up to R or Python, we have some specialty built tools to definitely help them make that leap from Data Classroom into Python. One other thing I'll say is that just the general um, role of tidy data in Data Classroom and the way that our data sets are set up and the way that the student or the tool helps students is based on the idea of tidy data, where each variable gets one column and only one column, and every independent observation adds a row to the data set. This is sometimes called tabular data or long format data. And this is central to everything that we do at Data Classroom, both the data education that we do and the data tools that we build. This is not necessarily central to spreadsheets. In fact, spreadsheets don't work on this tidy data. You can actually, sort of select things on a whole bunch of different areas in a spreadsheet, and it sometimes leads to students making insane data figures, for lack of a better descriptor there, because it will allow you to sort of um, take things that are not the same variable, and you'll sort of treat them like they are, and that leads to really confusing data figures. It leads to you know statistical tests or models that just kind of fail. And with Data Classroom, the format of the data sort of reinforces that variable thinking. It makes it easier for students to make that jump to R or Python. So a couple of specifics about design decisions. We've really built Data Classroom around this idea that data visualizations that show only the summary statistics. So for example, like that graph on the right, where you have a bar, the height of which is showing the mean. We're fine with that kind of a visualization, but we know that it can mask a lot of the variation under the data set. So in Data Classroom, we always want students to look at something much closer to the raw data, like you see in the panel on the left, and then they can add an abstraction like the bars, and they can even choose to hide the data points and just show the bars. But we want students to know exactly what those bars are representing. So that's one thing that has gone into the visual design of Data Classroom. Um, another consideration in the design of Data Classroom is that we want our tools to be easy to use. However, that we are recognizing that easy to use is not necessarily the most important um, consideration, but what we're really going for is having a tool that helps students understand what they are doing and why they are doing it. So we want to make the operations explicit within the tool, and we prioritize that over ease of use, which is a high priority for us as well. And then finally, or not quite finally yet, but another thing that's this is just another example of that idea of making things explicit. And this is illustrating our graph-driven hypothesis test, where you can run a test like the two-way ANOVA that you see in this example, but we first want students to make a graph or a data visualization that is basically an illustration of the two-way ANOVA. And then from that illustration or from their graph, they will go on to apply the statistics. And again, that will help them understand exactly what is being done and why. Um, and then finally, and this is where the bridge to R comes in, we know that when learners are learning to code, they are frequently Googling for the code that they need, or these days they're asking ChatGPT for the code that they need to do something with their data. And frequently, novices they simply just don't have the vocabulary to find the example code that they need. And so our solution within DataClassroom U, and I'll give you an activity that you can use to get started with this, is they're going to make a graph first in DataClassroom in an environment that has sort of gentle guide rails. And then if they want to get the code to do that same thing in R or Python, DataClassroom will give them that code, and it'll also be annotated in a way that helps a learner understand the anatomy of what's going on in there. And so that is our story. That's a little bit on the basics of our design there. And the second thing, or the thing I want to show you now, is the DataClassroom resource library. So with that, I'm going to switch my screen share over to DataClassroom. And are you all seeing my dashboard on DataClassroom now? Did we move away from the slides? If you can see my dashboard, give me a little nod there. Okay, great. So this is the DataClassroom dashboard, and I'm just going to go into the resource library for 1 second here, and just sort of acknowledge that I think one of the barriers to getting students to do things with real data is finding the perfect data set that fits for the situation that you're trying to illustrate. If you want, to have a data set that is very friendly to a t-test, or very friendly to an ANOVA, or is suitable for a linear regression, sometimes you can spend a lot of time, finding the perfect data set for that situation. We have a resource library here in DataClassroom that has over 100 curated data sets. You can search them by text, and that's up here in the right hand. You can search them by concepts, and this is like where you would maybe search for, a data set to do an ANOVA with. You could search that way. You could also search by subject, and this is kind of, more what subject area they fit with. And so, like, if you were teaching intro bio, you might look in biology, life science there. I'm going to open up a data set, this one called Life on the Edge, Biodiversity of Coastal Habitats in Nova Scotia. And I'm going to open up the data set just to show you an example of what the data sets are like in our resource library, and what materials come with them. This is the data table view that you're looking at. This is a pretty modestly sized data set. You can see it has 90 observations in it. And if I go over to this assignment tab, we can look at the pre-made assignment that goes with it. And all of the stuff in the resource library will have some background information. And we kind of think about what is the least the student needs to know to make sense of these data. And that's what we aim to have included in the background information. We also always have some information on the data set itself. And you can see, like, here, there's a little map showing where the data were collected. There's a little bit of the story on the methods here of what, how these data were collected, what the researchers did. And then there's information about the variables themselves. Are they categorical? Are they numeric? What do the values represent if they're categories and there's abbreviations? What metadata do you need to understand that? Um, and then there's activity where students will work through the data and basically go through an analysis to get at the main questions in the data set. To kind of show you the graphing tool, for example, this data set, the researchers were looking at coastal habitats in Nova Scotia, some of which were exposed to the waves in the Atlantic Ocean, others which were sheltered by rocks or their orientation, and then comparing biodiversity in quadrats that were measured in both of those habitats. And so, like if I grab this variable called habitat, we can see that we had 45 samples in the exposed habitat, 45 in the sheltered habitat. And then if I go and look at some measure of biodiversity, like say species richness, we can look at that and right away get a picture. We can see all of the data from the sheltered habitat, all of the data from the exposed habitat. In making this comparison, students might want to add descriptive statistics here. And so like here, I've added these box plots highlighting the median, this kind of classic box and whiskers plot. And we can look at the comparison there. And, we can see that the median for the exposed group is 2.19 and the median species richness for the sheltered group is 1.12. So it's about doubled in the exposed group or close to doubled there. If a student wanted to launch a statistical test from here, they could go up here and launch this graph-driven hypothesis test. It's recommending a t-test here. I could turn on the advanced options. We could see, a bigger suite of choices, but this is still a t-test recommendation. And in the course of running that, students are going to get this, why are you using the t-test? Well, this is the test we're looking to compare to see if the average value of a numeric variable is different between the groups. We can tell that, this is a t-test here. So it answers some of that, why am I doing what I'm doing? And then they can run that test and get their standard statistical output, their degrees of freedom, the test statistic, the p-value. They can dive in this little explainer and get a little bit more help on the interpretation of their p-value. So it makes it, I think, quite a bit easier for students to get into those key questions where they're really evaluating the data and not spending a long time on the mechanics of simply just producing the graph there. And again, I think this speaks to the time constraints and some of the differences in backgrounds that some of you talked about in the beginning when I asked you, what your challenges are in working with data. And I think again, just the resource library can save you time as someone who's preparing the course, and then it can also save class time in making it quicker for students to get to the higher order thinking or the content that you wanted them to look at real data with, and you could spend a little less time sort of getting to that point. If anyone has any questions, feel free to drop those in the chat. I am keeping an eye on that on one of my monitors here. Be happy to divert a little bit if you have a specific question. Okay, with that, I'm gonna stop the share for 1 second, and I'm gonna go back to my second main point, and I just want to cue some things up here as well. Get back there, and let me get my screen share back up to our third point here. And I almost have it. Okay, and we are back to the slides here. I want to, so sort of method number one or feature number one that can help you bring more data into your class by kind of lessening that preparation and time available is the resource library. And there's a couple of questions about that. Um, when you say resource library, you mean the lessons available? Yeah, that's what I'm when I say resource library, I'm talking about that collection of data sets in totality. There's 176 of them in there altogether. I think there are 107 of them that we say are appropriate for a college classroom. And so yeah, that's what I'm talking about when I say um, resource library. Um, and then there's another question from Sarah in the chat. Is there a section beyond just using a specific data set that would help students understand the different statistical analyses? Um, I would say, we're not necessarily set up to be like an intro course in that, but I would say that the table that pops up when you are looking at the options for the statistical tests can be quite helpful because that table sort of contains all of the logic um, to how a statistical test is chosen because it's showing you, sort of what kind of variable you have on X, what kind of variable you have on Y. It's showing you if we're assuming a normal distribution in the data. And so that can be very useful in a practical and applied sense in sort of learning when a statistical test fits. One other resource that we have in there, if you want to dive in a little bit more deeply in the nuts and bolts of how the statistical tests work, um, I didn't plan to show it tonight, but the interactive analysis, and if you go up into the search bar, that the general search bar that's at the top of the web app, no matter what screen you're looking at, and you search for interactive analysis, it'll sort of show that. But that's a great resource if you want to dive in more deeply um, to the math. But in all honesty, though, to answer your question, we're not set up to be, a survey course in comparing the different statistical tests. We're really set up to be a tool to get students into what we consider to be the more meaningful work with data more quickly there. And then to Judith's question of where can you find the resources? If you go to within Data Classroom, any screen within Data Classroom, and you go up to the little button at the top that says My Stuff, in that drop-down menu in My Stuff, you'll see Resource Library, and that will show you all of uh, the data sets and lessons that are in the resource library. Okay, and with that, I'm gonna move on to another example of sort of something that I think can help you bring more real data work into a class. Um, I think one of the things that can be done is having students do some work with data that they've collected. And this has been really popular among different university courses that are using Data Classroom. Oftentimes we see that they are more interested in our tools in a lab section than a lecture section. Not always, though. Sometimes they're used in the lecture or in both. But one of the reasons why I think that these tools can help students do more with their lab data is it can simplify those instructions for doing the tasks you want students to do. And so, for example, this was at an intro bio course at Sweetbriar College here in Virginia, and they were doing a simple butterfly lab where they were feeding butterflies in their lab, and they were measuring consumption in microliters of these sugar solutions that they were feeding the butterflies. And the data tasks that they wanted students to do was they wanted them to make a graph of this consumption for each of the different butterfly species they were working with. They wanted to list the means, the maximum, the minimum, the standard deviation for each of these by species. And this was what you see up on the screen. This was the original set of instructions when this course was doing this in a previous year with Excel. And so you can get a feel for the kind of instructions here. They're using several different Excel functions. They're using count, average, max, min, and standard deviation. And then they're repeating this by functions to make these graphs. There's a separate set of instructions, and actually Megan just sort of said, gave you the basics of going to charts and then said, hey, students, figure this out. I'm sure there was varying degrees of success with that or varying degrees of challenge. But when this was converted over to using Data Classroom for this is what all of those instructions could be boiled down to. And it was basically, first visually group your data by species, show consumption volume on Y and species on X. And we'll actually go through and do this. And then add descriptive statistics to your box and check the box for values. And that would output all the things like maximum, minimum, standard deviation, and mean. And one thing I'll also say, I'll just put in a plug for this. If you are looking at our tools and considering making a switch, but you're sort of lamenting the fact that you have to convert all these Excel instructions or sheets instructions into something else, we can help with that. So if you say you're interested in making this conversion and you send us your lab instructions, we're happy to help with that conversion and doing some of that grunt work in writing it over, because we know exactly what the instructions would be in Data Classroom U, and so we're happy to help with that. This is the kind of figure that Megan's students were able to produce in their lab, where they had these four different species of butterflies here. And you can see this graph they produced. And I'll go in and we can make this one together with the data here. I've got this data set up. So here I'm going to pull up the student collected data set. And yes, it is the question, is it possible to input your own data? Yes, absolutely. And I could even, since you asked, I'll go to the dashboard and I'll just repeat that process. I did it ahead of time, but just to show you. So here's the data set that was collected, and you can see it in sheets, right? So here's what the data look like. And I'm gonna just simply go up and grab the web address of this data set. And I copied it. And I'm going to go back to the Data Classroom dashboard, and the stack of green buttons here, import data. And so from here, it's asking me where are the data coming from. And so the fetch is from Google Drive. The upload is if it's a file on your computer. The copy paste is if you want to copy paste the whole data set right into this cell, which is pretty handy sometimes. Or you could create a blank table and manually fill it in. But I'm going to go to the fetch, and I'm going to enter in the web link. It's checking the file as public. You can bring in a file that's not public, but you're going to have to browse through your Google Drive and authenticate it that way. But I'm going to click fetch. It's going to bring in the data set. So this is exactly what students would do if they're bringing in their data. And we'll give it a title. And now we're working with the data. I've brought them in, and we're starting students on this checklist as well. And you can see everything from the import, we're all green check marks. So we're ready to roll. And this flow chart up at the top guides students through preparation, visualization, and then statistics with their data. And this preparation, it wants us to do two things. And these caution triangles are outlining what it wants us to do. One, we need to tell the computer what type is each variable. Basically, is it categorical? Is it numeric? Is it something else? Most of the time, we need to say, is it categorical or numeric? And then it wants us to enter in some metadata about this file so we know what it is. And I'll say I'll fix these things. And so I'm going to go through, I'm going to treat year as a categorical variable. I'm going to treat species as a categorical variable. I'm going to treat sex as a categorical. We're going to treat wing wear as a categorical. And we have some blanks, and I'm going to choose to leave those empty. And then forewing length, that's numeric. Weight in milligrams, that's numeric. Total sucrose solution consumed, that's numeric. And consumption volume in milliliters, that's numeric. So I've set those up. And then a description, I'm just gonna, put a note in this file so I know what it is. This is me using Megan's class data in a webinar. So I won't be confused if I come back to that. And from there, I've got the data. I'm going to save that so I don't need to repeat that. I saw there was a question about what's the difference between categorical and numeric. Well, numeric data are what we might call quantitative data, and these are numbers that are measured, right? And so these are numbers that are measured where the numbers actually correspond to a numeric value. Categorical is data where these are not measured. These are, considered categories. And I think that's obvious for something like sex, where we have these butterflies are either F for female or M for male. A situation where a column where that might not be as obvious is year, where year, I decided to treat year as a categorical variable so that I could use it to group things later on. But I could choose it I could treat it as a numeric variable, and that would be fine. There'd be different analyses I could do, different graphs I could do. But this is years and dates are tricky, or year and time is tricky because sometimes you want to treat it as categories. Sometimes you want to treat it as numbers. I'll go categories here. There was also a question of, can you take data from a Google form? Not directly, but of course, if you can put Google form data into a Google Sheet, and you can bring Google Sheet data into here. The other thing I'll show you is, say that was a Google form and I took survey data, I can open this toolbar on the left and go to reload, and it remembers the address to the Google Sheet where I got the data. And so if I have a newer version of that data set, I can click this reload button and it will bring in the most recent version from the Google Sheet. So that's also very useful if you're collecting survey data from a Google form that's going to a Google Sheet, and then you're bringing it into Data Classroom. If you collect some more data, you can bring in an updated version of the sheet there. So I think I've answered those questions. There was also a question about the resource library, about them having various goals and specificities that can help you teach different aspects of data. Yes, and I would say probably the search field that's most relevant for that is the concept search, where you can find different data sets that, based on the variables they have in there, are suitable for either different kinds of graphs or different kind of stats tests in there. So they're not necessarily lessons on those things, but they're data sets that will work in those situations. And yes, we will be sending out the recording of this as well, and with any of the data sets and materials that I use as examples in here. Okay, so back to Megan's class example, the kind of graph they were really interested in, looking at the consumption and looking at it across species and getting descriptive statistics and some values for those. And so here, you can see off to the right, I've generated a table that has the mean, the standard deviation, the minimum, the maximum, and I've done it by species, and we've produced the graph. So, once we spent a while talking about the data upload, but to actually just output that information was very, very quick to do. and it can save time, and it can make these sorts of things a little less daunting to do in a lab situation there. Okay, in the interest of time, I do want to just really quickly show you the sort of last point here, and I wanted to show you a bridge to our starter activity, and I'm going to include one in the follow-up just to show you. I've got it ready here, so this will definitely be coming in the follow-up materials. This is a simple activity where there's a basic script that guides through students through the process of making a histogram in R and plotting it, and then making some changes to the histogram. And then the second part of the activity, which is what I want to show you now, is where they will actually go through in Data Classroom. And let me pull up a different data set to illustrate this with. They'll pull up a data set in Data Classroom. I'm going to use this one that is called Cicada Sex Education. It's one of my favorite demo data sets. So if you've been to my webinars before, I imagine I might have illustrated something with this data set before. But what I want to show now is I'm going to make a graph. I'm going to plot head width, and I'm not going to look at it as dots here. I'm going to look at it as a histogram like this by going into the rectangle-based graphs. And I'm going to launch the graph-driven hypothesis test, but I'm doing this because I want to do this try it in R. And when I click this button, it's going to give me the code to make this figure in R. And you can see each section of this code is annotated. I'm going to also do something. I'm going to include the data in the script right here. And so this saves me in a teaching situation. If I don't want to start with file paths and bringing data into the R environment, I can put the data directly in the script, and that's what I've highlighted in yellow here. But I'm going to actually take the whole script, and I'm going to go over to my R Studio here, and I'm running it in the cloud. I'm running it in Posit Cloud, which is an R environment that I highly recommend if you're using R in a teaching situation, because it ensures that every member of your class is using the exact same version of R. That is one thing that can be extraordinarily difficult when you're in a teaching situation, is you've got, say 20 students in the room, and you've got each of them running slightly different versions of R on their own machines. That can make it, pretty challenging. And I apologize here. My workspace, it timed out while we were undergoing the webinar here. But as soon as I get it open again, I will show you what this bridge to R can do. Let's see. Okay. So this is actually in this workspace I developed. I was recently teaching an online class through Georgia Southern University. I did a similar course through University of Virginia as well. But I'm going to take here, and I just pasted in that code up here in the upper left window. This is sort of my script writing window. And I pasted in that code in its entirety that I pulled out of the bridge to R. And then I'm going to just execute this line by line. And you can see this, we produce this data figure with that code that came out of the bridge to R. And so you can see we produced this histogram here. And now students are free to take this, and what I have and again, in the interest of time, I don't know that I'm going to go through all of it, but one of the things you can have a student do very easily is start manipulating this code. And you can find the part in here where we've got this linear color scale that's ranging from sort of purple to this kind of cream color. And you can have them, swap in a new hex code, and then this graph will be going, instead of from purple to beige, you can have it go, from red to green, or red to yellow, or something like that. And so that's the basis of that activity, is sort of walking through it manually, then walking through it in Data Classroom, getting some code from the bridge to R, and then taking that code, running it, and then manipulating it within R. And that's sort of something that I think can help students take that first step toward working in R. So I showed you several different things there in just the short 45 minutes that we had together. If you have any questions at all, feel free to reach out to me if you want to talk about any of these ideas further for a course that you're teaching. I'm Aaron at dataclassroom.com. Happy to chat about this. And yeah, hopefully, some of these things either bridge to R, or having students work with their lab data in Data Classroom, or just pulling something from our resource library